So we'll talk quickly about current. Electric current is a flow of electric charges. Technically, current really is the flow of electrons through the circuit. If we do it by creating a potential difference, I like to kind of demonstrate it as the battery is sort of the thing that brings the electrons up the hill, right? And then the electrons flow down the hill. That's current, okay? We call this potential difference or voltage, okay? So that's what that does, is it brings it to the top of the hill. Now we talk about conventional current, which is they've always and forever when it comes to current, they've always talked about it as a flow of electrons, the flow of a positive charge, or the flow of a positive charge around the circuit. Good morning.
We never heard of that.
Okay, there was no bell. But the conventional current flows in the direction of positive charges. So we've got current flowing one direction, but we always talk about the direction a positive charge would flow, when in fact it's the opposite. So when we talk about conventional current, we're talking about the flow from a positive terminal of the battery to the negative terminal of the battery. We use the symbol I for current. And we talked about where they flow from and to, from low potential or current flows from high potential to low potential. And then electric current is the amount of charge passing a given point in an amount of time. So if you were imagine and you were to just sort of like say, okay, well, here's a bunch of little electric charges in a wire, right? If you were to kind of put a little sensor here, we call this an ammeter, and we're going to do that today, okay? What we're going to do is we're going to insert an ammeter in series. Did you guys remember? Did you guys from the last lab? Do you remember from the last lab? We talked about two different types of circuits. One was called a series circuit, and one was called a parallel circuit. Do you guys remember those? Okay. Well, a series circuit is when there's two resistors that are both in the same loop, okay? Now you can take those same elements and you can put them in different formation, which we call parallel, where you sort of build two circuits. Do you have two branches, right? This is series, this is parallel. Okay? Two things that we learned about what was better about series. Series, that you're going to have dimmer bulbs, right? And that's because there's more resistance. They're having to share the current, essentially. Okay? Here in parallel, they each have their own path back to the battery, meaning they both get supplied the same amount of voltage, thus the same amount of brightness. So these are brighter than those. That's better. And the second reason it's better is what happens if this one burns out? That one stays on. That's the fancy version of Christmas lights, right? If this burns out, what happens?
They all burn out.
They all burn out. That's the cheap version of Christmas lights. Okay, so that's what we're going to do today. Is we're going to insert an ammeter into a series circuit, and we're going to measure the current. And I'm going to teach you sort of how to do that. Okay, we're also going to insert the ammeter into a parallel circuit. And I'm going to ask that you guys try to figure out sort of how it works, like how the current works in a series and in a parallel, okay? So I'm going to ask you to insert an ammeter before the two resistors, between the two resistors, and after the two resistors. Now you'll just do one ammeter at 3 different times. But I'm going to ask that you do that today. And what you're going to do is you're really going to be measuring the current in 3 different spots on the series circuit, okay? Then we're going to do the same thing. We're going to insert an ammeter here. We're going to insert an ammeter here. We're going to insert an ammeter here. And we're going to insert an ammeter here. And what I'm going to ask you to do is I'm going to ask you to figure out what is the current in all these different spots and see if you can come up with sort of a formula that sort of relates what happens to the current in a series circuit and in a parallel circuit. Well, I'll guide you through that a little bit today. Now remember, we've done a few problems that deal with current. The formula for current is Q over T. Q stands for charge. Good. It's measured in coulombs. Good. T stands for time. And so really this is just a measurement of how many electrons are passing a given point in the circuit at any given point in time. Now that's going to be a lot of electrons, right? Okay, so we remembered, and we're going to measure this value in what we call amperes, commonly called amps. But really, if you look at the unit, or if you look at the formula, it's a coulomb per second. That's really what they're measuring. If 1 coulomb of charge went through a wire in 1 second, it would be 1 amp. Okay. Now there might be more or less depending on the situation. The other thing that we learned how to do is if they gave us a number of electrons, we can convert from the number of electrons to the amount of charge, right? By just saying that each electron has a charge of 1.6 times 10 to the negative 19th coulombs. It's technically negative, but remember, it's not. We're just going to make it positive in this situation because it doesn't really matter. So you would just do this times this in the calculator, and you get your value. Now, if they gave you if they asked for the number of electrons, they might ask you to solve for the charge and then do the inverse of this. So you guys that are in honors, you guys are going to have to approach a problem that is like that. Okay, so you're going to have to go from electrons to inserting it into your formula, I equals Q over T. Okay, and so you're going to have to do 2 steps. The CP, you'll probably just be plug and chug in that situation, okay? So we did a few of these problems. You guys should be good to go on that. What do you say we give this lab a run? Sure. Copy? All right, let's do this thing.